Hello everyone, I want to show you how I built a cool little boost effect. Let's break this effect down a little bit. The first element of the boost is the speed of the ship. During the boost, it travels much faster. Next, we have the camera. On the one hand, when the boost engages, the camera drops back a bit as if it's getting left behind. It then slowly catches up with the ship again as the boost continues. To give the game an added sense of speed, the camera starts shaking pretty strongly during the boost. Last but not least, we have the thrusters. During the boost, they are much larger. We also have these electrical sparks flying out from the ship. Okay, let's get into building this. I've already done a little bit of setup here. So we have a method here that basically gets triggered when we press a button on the keyboard. This allows me to test the boost mechanic much more easily. We have the two methods, apply boost and stop boost. So let's start with apply boost. The first thing we want to do here is increase the speed of the ship. At this point, I want to deviate a little bit and talk about how the ship is actually traveling around the cylinder. So here we see our ship flying. If we look at the scene view, we see that the ship is actually standing still. What's moving is the cylinder itself. So the cylinder is just rotating. That's how this whole thing works. That means to increase the speed of the ship is actually to increase the speed of rotation of the cylinder. So let's do that. I've added a method here, start boost, that merely increases the speed of the cylinder. That should take care of increasing the speed of the ship. Okay, let's run this. Let's engage our boost. Okay, faster. I like it. Next, let's add that camera shaking effect during a boost to give it that extra sense of speed. The way we get the camera to shake is by accessing the Cinemachine camera's noise profile and increasing the amplitude gain. This is our camera. We see here it has this noise section. If we extend this, we see the noise profile, and we can also start playing around with these parameters. And if we increase the amplitude gain, we notice that the camera starts to shake. And that's exactly what we're doing in the script. Okay, let's run this. There's the camera shake. Nice. The next thing I want to do is I want to increase the size of the thrusters during the boost. To understand how this works, let's take a look at the way our thrusters are set up. In our ship, we have a series of particle effects. We have our regular thruster effects that consist of 4 different particle effects. Thruster 1, which we see here, thruster 2, thruster 3, thruster 4. This is what we see when we're just flying along in a normal mode. For the boost, we have this object here, which consists of a couple of more particle effects. Let's enable this object to see what it looks like. Let's disable our regular thrusters and enable our boost. Let's start from the bottom. We'll take burner 1. That's this white hot ball. The second one, and then the trailing burner here, and the one on that side. We can quickly take a look at these boost particle effects to understand how they work. Essentially what we have is a very small shape, virtually no spread whatsoever, and a very high rate of emission. And in addition to that, a fairly large size here. If we reduce, for instance, the rate of emission, we see that it's nothing more than a pretty standard particle effect from Unity. But of course, if we turn that value up to 20, it starts to really look like a continuous pulsating thrust. And that's basically how most of these are created here. The difference between these regular big ball burners and these boost burners that have this tail here is that these boost burners here also have a start speed, whereas the other burners here, for instance this one over here, does not have a start speed. And combining these two gives a very nice, really large white hot boost thruster effect. Last but not least, we also have these sparks here. I created a YouTube short that explains how I implemented these, so I will link to that short in the description. These sparks, however, they're only running once. Yeah, they're not looping like the other effects here, so they will only run once when we enable the boost object. And that's basically what we do by calling this boost thruster set active to true. By doing that, we set this parent game object to active, and that triggers or that enables all of these particle effects and causes them to run. Okay, let's check the boosters. Very nice. The next thing I want to do is I want the camera to kind of lag behind or fall behind when the boost gets engaged. The way we're going to do this is we're going to interact with this framing transposer in our Cinemachine camera. If we open this up here, we have a couple of properties. And the interesting one here is this camera distance. We're basically just going to increase this when our boost engages, and we're going to lower this, because right now it's just a bit too high up. It almost looks like a helicopter is following it. So the way we're going to compensate for that is we're just going to lower the screen Y to kind of give this cool effect of the camera falling behind. Okay, so to do this programmatically, we have to access this transposer component in our Cinemachine camera. Okay, let's give it a go and check the camera. Very nice. Cool. Now what's missing here is that the camera has to kind of catch up with the ship eventually, right? So let's implement that. Yeah, basically after the boost is triggered, I want the camera to slowly inch back or slowly catch up with the ship. So the way we're going to do this is we're going to call or create a coroutine. Bring camera back. We're going to use a linear interpolation to bring the camera back from its boost distance back to the distance where we want to have it when we aren't boosting, or at least to a distance that's close to where we want to have it when we're not boosting. It's okay if it's still a little farther away and that disabling or disengaging the boost, or when the boost runs out, that it then drops back into the normal position. But during a boost, I already at least wanted to start coming back part of the way. So let's interpolate the camera distance. We have to bring the Y position of the camera back into its original place again, so we will also linearly interpolate that back to a position that is almost the starting position when there is no boost. And yes, I am aware, of course, values like these that I'm using over and over again here should be constants, but I'm currently, as I've done in previous videos, just trying to get this to work right now, and I can clean it up later. Let's call our coroutine, and let's give it a go. Very nice, I like it. Okay, now for stopping our boost, we basically just reset everything to what it was before we started the boost. So let's start with the speed. Again, we're going to regulate the speed by changing the cylinder's rotation. I created a handy method here, stop boost, that does this for us. Next, we're going to reduce the camera shake again. Now, the reason I'm just decrementing it and incrementing it by this value is because as we start, or as the ship gains velocity, even without a boost, eventually the camera starts shaking. So the boost should just make it shake more. That's why we add a factor to the gain when we apply the boost, and we remove that factor when we stop the boost. Let's turn off the thrusters, and let's bring the camera back to its original position. Let's try this. So I will trigger the boost, and now I will stop the boost. Great. Okay, looking pretty good. Okay, that's it for today. Thanks for watching. See you next time.